Hi again, everybody, and welcome to today's free virtual program. My name is Martha Waldron, and I'm the Community Engagement Manager at the Maryland Center for History and Culture. I want to welcome everybody and thank everybody who is joining us in the audience, and extend a special thank you to those of you who made a donation when registering. We very much appreciate your support and want you to know that your donations help us provide programs like this one. So if you'd like to make a donation in support of today's program or future programs, you can head to mdhistory.org/donate. Today's conversation, which is all about changing weather and climate patterns in Maryland, will provide context for one of the current exhibitions on view at the Maryland Center for History and Culture, Losing Winter. Losing Winter is a participatory project and exhibition which utilizes the photograph collections at both MCHC and the University of Maryland, Baltimore County, to juxtapose and complement collected memories of winter by the exhibition's featured artist, Lynn Cazabon. And so with that, I will introduce our participants. Lynn Cazabon is the artist behind Losing Winter and is a professor of art at the University of Maryland, Baltimore County, where she is also the director of the Center for Innovation, Research, and Creativity in the Arts. Dan Barrie is a program manager for the National Oceanic and Atmospheric Administration Climate Program Office. And lastly, Erin Posthumus is the outreach coordinator for the USA National Phenology Network at the University of Arizona and is joining us from the Southwest. So before I turn the conversation over to Lynn, I just want to remind everyone in the audience to ask questions throughout the program by using the Q&A function at the bottom of your screen. We'll reserve some time at the end of the program to address your questions. Thanks so much for being here, and I will turn it over to our participants.
Thank you, Martha. Hello, everybody. So as Martha said, I'm the artist behind Losing Winter, which is both the name of the exhibition at the Maryland Center for History and Culture, and also an ongoing art project of mine. So Losing Winter is a participatory artwork. It's also an augmented reality mobile application and an archive of memories and emotions about the season of winter. So the seasons are not what they used to be, in my opinion. The baseline, or what is considered to be a normal winter, has changed significantly within my lifetime, as it has for the other seasons. I've observed a gradual erosion of the distinction between the seasons, along with hotter summers and milder winters. Losing Winter is designed to foster conversation about climate change at the local level and at the human time scale, and to reveal it not as an abstract, faraway crisis, but as one that is unfolding in real time right here. To lose winter here in Maryland is connected to the numerous climate change related impacts, both large and small, that are happening around the world. The title of this panel, Let's Talk About Weather, refers to the innocent conversation starter that I use to ask people about their memories of winters past, as a means to reveal the personal and cultural losses associated with climate change that run in parallel to its environmental impacts. The Losing Winter exhibition at the Maryland Center for History and Culture, which is on view through July 2022, displays the video recordings of winter memories from Marylanders of different ages, which I collected and displayed. They're displayed within the context of an exhibition of photographs and moving images showing scenes of winter in Maryland over the past 100 years. The exhibition was curated by myself and MCHC curator Joe Trapia. The images in the exhibition come from the collections of MCHC, as well as special collections at UMBC, where I'm on the faculty. This photograph by Aubrey Bodine of Groundhog Day, you go to that slide, Martha. is from 1945. This is one of my favorite photographs in the exhibition. It's a staging for the camera of the annual ritual of Groundhog Day. A. Aubrey Bodine is a well-known Maryland photographer. Groundhog Day is an American cultural practice that actually traces back to an ancient Christian tradition to predict the end of winter. I invited Dan and Erin to join me in this panel today so that we can delve deeper into the science of climate change and to better understand the complex ecological ramifications that come with the shifting of the baseline for winter in Maryland. I also approached veteran WJZ meteorologist Bob Turk to be part of this panel, but he was not able to. So instead, we're going to play this short video excerpt from an interview that we did with him as a way to begin the discussion about the relationship between weather and climate.
I started keeping weather records where I grew up in Pikesville from the late 1950s to the late 1960s, actually. Here's May 67. I kept every day's record, highs and lows, precipitation, snowfall, and notes about each month, each day. And some of these notes are pretty interesting because, I mean, I said, here, and I remember this because I was in school this day. We had snow on May the 1st, 1963, okay? It was one of the last snows we ever had. And Western Maryland had 3 inches. But all these records here, I kept them all this time because I thought, I don't know, I spent a lot of time with this. Frosty in Western Maryland, this is like August 1964. I've always just been interested in weather. As you can clear, and tell you something, some of these temperatures we had not seen in a long time, especially in the wintertime. I can honestly say that probably in the last 20 or 30 years, we've had very few incidences of below 0 temperatures, even below 5 or 10 degrees, even with snow on the ground. I mean, you can look at some of the stats. All these, I have a lot of days, almost every year we had below 0 temperature. Back in the late 50s to mid upper 60s, late 60s, even to the 70s. Now, it doesn't necessarily mean you didn't get big snowstorms, because for snow, all you need is 29, 30, 32 degrees. So we did have some big snowstorms, but not necessarily super cold temperatures. And that all has to do with the jet stream. When the jet stream is weak and it's not bringing a lot of Arctic air, like this past winter, we only had really a month of winter weather in February. I was in Florida and came back, and that's this past February. We had snow like every 3, 4, 5 days. That was the only real winter we had this past winter. Other times it was in the 30s and 40s and 50s. Yes, I've seen less severe winters, particularly in the last 20 years. Yeah, less episodes of very cold conditions.
Anyway, he's talking about keeping records of Maryland weather over decades, and definitely has observed a warming in winter. So the way that I explain the relationship between weather and climate to myself and to others is to use the analogy of mood versus personality. Weather is like mood. It changes day to day or minute to minute. It's transitory. Climate is like personality. It's the pattern of weather over a long period of time in a particular place. So I want to turn to Dan and Erin now to ask them to describe the relationship between weather and climate from the perspective of their fields. Maybe we can start with Dan.
Yeah. Hi, Lynn. Can you hear me? Okay, great. Well, you hit me with a really interesting analogy right there, the mood and personality. I love that way of describing it. I actually haven't heard that before, but like mood is this kind of emergent property of personality, which is more immutable or consistent. That's really pretty great. I got to add that to my repertoire. I wanted to mention just at the outset a couple of pieces of information about me, background. So first of all, personal background, I'm from upstate New York. So I have a huge sentimental attachment to winter. I have lots of photographs in my family of the exceptional winters that I experienced in my childhood, myself sitting by massive snowbanks from the snowplows. They used to have to dump snow in the river, in the Hudson River in Albany, to get rid of it at a certain point in the winter. And I do miss it, and I resonate with the sort of sentimental aspect of the title of this exhibition. I also would just want to mention what I do professionally. I'm a program manager, and I'm involved with climate modeling. That's generally my training and background. I work on a wide array of issues, including drought and climate prediction and projections of the future and things like that. So to get to Lynn's question, I have a couple other analogies that I like to use to explain climate and weather, and I think they mesh really nicely with the mood and personality analogy that Lynn led off with. So one thing that some climate scientists or weather scientists will often say is that climate is what you expect and weather is what you get. And there's a good example of that analogy this week in Baltimore, where we're having really wonderful weather in the Mid-Atlantic region and in the Baltimore region. This week, our high temperatures are in the upper 60s, our low temperatures have been in the upper 40s, near 50, and that's about 5 or 10 degrees warmer than what we would expect. And that's a good example of how, if you look at data records over a very long time period, like Bob Turk was talking about in his video, you may come to expect a certain average temperature for November 10th. But then the weather is highly variable within those constraints, and you can get different conditions than the average. Another analogy that came to me a number of years ago with the update of the Cosmos program that was released, I think about 5 or 10 years ago. It's really worth watching, but they had a great analogy for weather and climate that gets to some of the physical aspects of the differences as well. And that's what's shown on the screen here. So if you're having trouble making this out, this is a person walking their dog. And the blue marks on the screen are the footprints of the walker, and the red marks on the screen are the footprints of the dog. And what you can see here is that the dog is generally going in the direction of the walker. The walker is basically guiding the dog, but the dog is varying quite a bit around that path that the walker is taking. And that's kind of similar as well to weather and climate. And it also gets at something important, which is that climate really gets down to the way that our Earth system, our atmosphere, our oceans function, and the limits on those functions. Baltimore can only get so hot. It can only get so cold on a particular day. There are limits to that are set by the physics and chemistry of the system, the climate of the system. But the weather can vary quite a bit within those parameters that the climate system sets for it. So that's another way that I like to explain it from a scientific perspective. And I guess we'll go to Erin next.
Yeah, thank you. I really appreciate the invite and being part of the panel. So my field is more related to how we see these changes in climate and weather from the perspective of plants and animals. So my field is called phenology, which is kind of a jargony word, but basically it just means the seasonality of plants and animals and how climate impacts those events. And so my organization was actually established a little over 10 years ago because people recognize that these changes that happen in plants and animals are a really great indicator of climate change. And so we can use these kind of activities to see how plants and animals are responding to differences from year to year. And so to answer the question about the difference between climate and weather from the perspective of plants and animals, I really think of it as kind of this same idea of long-term versus short-term. So plants and animals have kind of evolved to be suitable or suited for different climate regimes or climate envelopes or kind of different conditions. So you might have a particular plant that has a limitation where it can't function below a certain temperature or maybe above a certain temperature. So there's certain restrictions on it in that respect. And that's in the long term. These plants have evolved for these conditions, and so you see them located in certain places with typical climate. And animals for the same reasons. Things like insects might not be able to fly around when it's too cold, might dry out when it's too hot. So there's limitations on their activity as well. And then from the perspective of their life cycle events or activities, that's really where the weather comes in. So a lot of plants and animals have things that we call cues or triggers, where there's a certain amount of temperature or a certain amount of precipitation that happens that kind of triggers something to happen in that life cycle event. So if you think about springtime, there might be a particular plant or animal that comes to mind for you that's kind of a symbol of spring. And a lot of times, if it's something like a deciduous tree, that might be the first leaf or the first flower that you see on that plant. And the plant has to have something to tell it that it's time to do that activity. If it did it too early in the winter, it would freeze. And so it's evolved to have these certain conditions where it might have a certain amount of temperature that needs to accumulate before it'll start its activity. And so that might happen at a really different time from year to year. You could have a year where there's a warm spring where that plant might leaf out or flower earlier. And then in another year, it might be a later one. So there's a different amount of flexibility in that for different species. And that really changes for different species. And I'm sure we'll talk about it later, but in terms of native species versus invasive species. So there's a lot of differences in how those plants and animals can respond to these variations in temperature and precipitation from year to year.
Well, thank you. Yeah, actually, that's very interesting to think about climate as an envelope or boundary that you kind of plants and animals exist within, and when you get outside those boundaries, you have problems. Okay, so turning back to Dan, I wanted to ask about your observation of winter temperature patterns across time in Maryland, and if you could tell us about how that connects to climate change in Maryland. What does it say for our future?
Yeah, sure, Lynn. So I love both science, obviously, but also visual art as well. And there's a scientist a number of years ago at the University of Reading in England who published this simplification of our temperature data, and they're called warming stripes. And they've actually been all over the event in Glasgow this past couple of weeks. There's actually a chandelier in the main event hall at Glasgow that has these warming stripes hanging from the ceiling. It's really beautiful. But what this is showing is temperature data since 1880. So if you start on the left-hand side of this image, you're in the year 1880. And if you go to the right-hand side of this image, you're then in the year 2020. And so each of these columns is an individual year, and it's color-coded according to how cold or warm that year was compared to the long-term average. So these dark blue colors mean quite cool years compared to the average, and the bright red colors, the deep red colors, mean quite warm compared to the average. And this particular image is for Maryland. You can actually go to the website on the screen here and make it for your own state or country. And what you generally see is that there's a lot of variability in temperature in Maryland. But then you also notice on the right-hand side a lot of red and increasing amounts of red and consistent red year after year. And that's really the trend since 1980 being quite strong. There's a quite strong warming trend in Maryland. And before that, it was marked by much more variability. And this is the result largely of greenhouse gas emissions, actually almost completely greenhouse gas emissions. When we look at the different causes of climate, the different controls and boundaries and envelopes on climate, it comes down to the greenhouse gas emissions, which have accelerated significantly since about 1970 and 1980. And in the winter in Maryland, we've actually warmed a little bit more than the year on average. At this point, temperatures have increased about 3.5 degrees. And as I mentioned, the rate is quite large over the last 40 years in particular. This is a figure that I wanted to include because I think it'll help frame some of what Erin has already talked about and what she's going to talk about, which is the number of days per year in Baltimore County where we get below freezing temperature at some point during the day, usually at nighttime, where it drops below 32 degrees Fahrenheit. And this is also a graph over time. If you start on the left-hand side, you're in about the middle of the 20th century, around 1950 or so. And the right-hand side is 2100. So the gray bars are showing you actual observations of the number of days per year when we get a temperature at some point during the day less than 32 degrees Fahrenheit or freezing, which has really key impacts on the ecosystem. And we used to get about 110 of these days in the middle of the 20th century. Now we're getting about 80 to 90 of these days per year. So that's a pretty significant decrease. That's a loss of nearly a month of these temperatures below freezing. By the middle of the century, the projections from climate models indicate that this should continue decreasing and will arrive at about 65 to 75 days per year below freezing. And by the end of the century, significantly less than that. So it could be between 40 and 60 days per year. There's a lot of uncertainty around this. There's a lot of variability, but the trend is really clear, both in the observations of the past and also in the model simulations of the future, that days that get below freezing are going to become increasingly rare. And that does have really important effects on both our society, but also especially on our ecosystems, as Erin's going to talk about.
Yes, I actually can't help but think of mosquitoes that don't die and they don't have freezing, and then we have more mosquitoes. Actually, I wanted to turn back to Erin and ask about the USDA plant hardiness zones in Maryland. I know they have shifted over time, and I was wondering if you could speak about that and how that impacts the community of plants that we have in Maryland.
Yeah, sure. And I definitely hear you on the mosquitoes. We actually still have mosquitoes here in Tucson right now. So we're definitely feeling the impacts of warmer weather later in the year. Yeah, so the plant hardiness zones, they're a way to kind of think about this idea of that climate envelope again from the perspective of plants by thinking about what the average minimum temperature is for a particular location. And so there's a big map of the US that has bands of where these zones are for different locations. And it kind of gives you an indication of what plants will survive and thrive in different spots across the country. So definitely things have been shifting. These hardiness zones are only updated about every decade or so. I think there was an update in 1990 and then another one in 2012, and that was the most recent one. So this is a chart that shows the hardiness zone for Baltimore. And the one on the left there, the 7B, is the current hardiness zone for your location there. And what that means is basically the average minimum winter temperature is estimated to be 5 to 10 degrees Fahrenheit. So you wouldn't want to plant anything that can't handle a temperature below that degrees. And so the other things on this chart show the predictions for how things will shift in the future based on the different emission scenarios. So the lighter gray on the left for each of the kind of decades show the low emissions, and then the right shows the higher. And we can see that if we go out to 2099 there on the right, you're actually looking at a prediction of somewhere between going just up to 7B on the low emission side, up to 9A on the high emission scenario. And 9A currently is actually the condition for Florida. So if you think about how things are going to shift, plants that thrive in Florida are the ones that are going to thrive in future Maryland. So it's quite a big difference there. And so kind of practically what we can think about in terms of how plant communities and animal communities are going to change, it's really uncertain because there's a lot of other things going on with what could impact, whether a plant or animal can establish and actually do well in a particular location. The hardiness zones are good at telling us what the minimum temperature requirements are, but there's other considerations too, like the maximum temperatures, the amount of precipitation. It's interesting that Tucson and Seattle are actually the same plant hardiness zone, but we have totally different plants. So there's a lot of other things going on. But if we do have this shift to, a higher minimum temperature, we might see changes like more invasive plants coming in, things that, do well south of here or south of Baltimore will probably do well in the future in Maryland. So thinking about things in the Carolinas or further south than that, might thrive and do well in the future. There's also differences like if you have a longer growing season in plants where they're able to start their activity earlier and then continue that activity later because they don't have that cold cutoff anymore. There's lots of different things that can happen. And one example is with invasive insects in particular, they're actually able to undergo more life cycle events or generations. So you can have, instead of one round of mosquitoes, you might have 2 rounds of mosquito generation. So the population can grow quite a bit. So that's one thing that people are already kind of thinking about and concerned with there.
Yeah, actually, I was going to ask you a follow-up on the non-native plant species because plants, I think they can't travel, but it's not so easy for them to travel. But does that mean that the non-native species that we have here, or we already have many in Maryland, are just going to increase?
Yeah, yeah, there are definitely many ways that invasive plants can travel. People can move them inadvertently if they, go down and go for a hike in the Carolinas and then they come back, they might be spreading grass seeds or things like that. And so in the new climate that exists in the future, then they might be able to do better than they would have before and actually establish and start a population there. And then things like insects are pretty easy travelers as well. Things like cut wood that's moved in between for firewood in different locations has been shown to move invasive insects. So yeah, there's definitely a lot of potential for invasives to move in.
Yeah, the landscape is changing before our very eyes. Dan, I wanted to ask you about, we talked about temperature patterns, precipitation patterns. That's certainly something I've also noticed is increased precipitation in Maryland. And could you speak about that and what that says for the future?
Yeah, sure. So in general, we've seen in observations a small increase in precipitation, average precipitation over the course of the year. It's a little more pronounced in the winter, but it's still a relatively small change so far. The climate models project that precipitation over the course of the year and in winter should continue to increase. It may be about an average of a 10% increase by the end of the century or so. So that's not insignificant, but it is a relatively small increase compared to the temperature anomalies that we are seeing and forecasting for the future. But there are seasonal changes, and I think particularly relevant to the theme of this exhibition in winter, snowfall is a complicated story. So in general, we've observed that the number of snowy days in Baltimore have already started to decrease. We used to have about 11 days with measurable snow in Baltimore if you go back to the middle or early part of the 20th century, and now we're down to about 9. So we've lost about 2 days a year where you're going to see some sort of snowfall. And the expectation is that that would continue over time. The largest reason is because Baltimore is often at this zone right between the warm part of a winter storm and the cooler part of a winter storm. And as the atmosphere warms and the region warms, more often than not, we may start ending up on the warmer side of the storm, the rainier side of the storm than the snowier side of the storm. And if you look back at a lot of the snow records for Baltimore, and you look for these storms that only brought about 3 or 4 inches of snow, they often are these type of storms called nor'easters, which come up the coast. And nor'easters have the potential to give us a foot of snow. A lot of our biggest snowfalls came from that kind of a system, or exclusively came from that kind of system, actually. But oftentimes those systems are located just a little bit too far to the west or too close to the coast, or there's not enough cold air. And so you end up getting more rain and less snow. And that's something that's kind of emerging in the observations at the present time. And we're kind of in this transition zone right now, transition period, where we would expect to see this migration pretty clearly towards a more rainy as opposed to snowy winter in the Baltimore region.
Erin, what are changes in precipitation? How would they impact plant communities in Maryland?
Yeah, so from the perspective of phenology, which is about the timing of life cycle stages, there's not a lot that's really known about how differences in precip are going to change phenology. A lot of the differences that have been researched in the area of the Northeast are more about temperature changes. It seems like in temperate areas, which have a lot of deciduous trees and things like that, they're more linked to temperature as a trigger for those life cycle stages. But certainly changes in precipitation will impact the plant just physiology and animals as well. So some examples, if you do have these precipitation events that they're maybe not just overall greater, but they're actually happening in discrete times. There might be like a flooding event followed by a dry period and then another really wet period rather than a consistent increase in rain. That's actually pretty detrimental to a lot of plant communities. The flooding isn't great for plants, because of erosion, loss of nutrients and things like that. And then if you have a really wet period that's followed by a very dry period, that's when you start getting higher risk of wildfires, because if you think about it, that wet period will increase a lot of what we call the fuel load, or the amount of plants that are able to then dry out and provide the fuel for the fire. So it's actually predicted that even areas that don't have a lot of wildfires currently will have more under future climate conditions. And then also the method of how the rain falls, whether it's rain or snow, can make a big difference for plants and animals as well. So snow is very insulating. It can kind of trap some heat in the ground, and that is more beneficial to a lot of plants and also hibernating animals. Whereas if you have really cold rain followed by a freeze, then you have a lot of ice. And so there's been some detrimental effects to plants there too, with limb loss and things like that.
Actually, I was also wondering if either of you could address this humidity. I mean, we talked about precipitation, but is there, I mean, I certainly feel like the humidity is worse in Baltimore since I've lived here. Is there anything you can say about, humidity and these patterns?
The first thing that comes to mind for me is ticks. So ticks actually require pretty high humid conditions. So if you have an area that will become more humid, that would probably mean that you'd have a higher risk of tick season becoming either more severe or longer.
Again, I'll mention the tick example. I think there's a climate indicator that EPA keeps on tick migration, or the expansion of the tick habitable zone, and it has been expanding further southward. And I think especially the Mid-Atlantic, there's been a lot of growth. On humidity, I'll use this as a nice platform to talk up the variable called dew point. So humidity is usually expressed as a percentage from 0 to 100%. And we know that when it gets near 100%, it's either raining or it's really unpleasant outside, or both. Dew point is more of an exact measure of the amount of water that's in the air at a given time. So it's actually expressed as a temperature. And I would advise folks to start looking at the dew point in their weather forecast, actually, because it'll tell you it'll give you that direct sense of how unpleasant it's going to be when you step outside. If the dew point's over 65 or 70, just stay in the air conditioning at that point. Erin probably gets a lot of nice low dew points out where she lives, which is great, in the 50s, I'm imagining. And right now in Baltimore, we have really nice low dew points. There is more water vapor in the atmosphere, though, which means that you're not lying to yourself and thinking that it does feel more humid or that there are higher dew points in the region. We are getting more days with more moisture in the atmosphere, and you do feel that experientially when you step outside. As an Albany, New York transplant, again, not a big fan of it. that change in humidity in the Mid-Atlantic. But
actually, here in Tucson, we fanatically track the dew point in the early part of the summer, because it means that the monsoon is on the way. And so once we get to 54, everyone gets really excited because we finally get our summer rain. So it's a positive here in the Southwest.
Oh yeah, you need it.
Speaking of more about precipitation, since I moved to Maryland in 2000, I'm originally from Michigan. I experienced the freakish snowstorms in 2003, 2010, 2016. Dan, I was wondering, do those big dumps of precipitation, indicate, are they related to climate change? Are they, in your opinion, were they a kind of tipping point that now we're on the other side of it? So we're getting less precipitation in the form of snow.
Yeah. Well, so I put together this slide with a few classic photos of Baltimore scenes from the 2010 storms in February. These are various times taken at various times over a 2-week period. This, for better or worse, these storms became known as Snowmageddon. I don't know if folks remember that. You may like that kind of nomenclature or not, but these storms actually started that whole trend of sort of humorous names for our snowstorms in the Mid-Atlantic. And they have happened more recently, actually. So if you look at data from the Baltimore-Washington International Airport, which goes back to about the 1940s or so, we've had 11 storms in Baltimore in this area that have accumulated a foot or more of snowfall, and 9 of them have happened just since 1980. So you have 9 of them in the last 40 years and 2 of them in the 40-year period before that. So it's not a large sample size, but one of the reasons that this might be happening is kind of going back to your question about humidity before. And we've always had nor'easters. We actually had a nor'easter in the mid-Atlantic about 2 weeks ago. It resulted in some flooding on the Potomac River and Baltimore Harbor and along the coast. Still too warm for that storm to produce snow yet this year. You have to get deeper into the winter for it to be cold enough for a nor'easter to produce snow. But one thing that's happening is these storms are now, when they're exactly in the right location, encountering more water vapor in the atmosphere. And water vapor ultimately leads to the generation of precipitation. So if you're supplying more water into that storm, it has the ability to create more precipitation than a storm in a drier environment earlier, for example, in the 20th century. So that may be one reason why we're seeing actually an increase in these very, very large snowstorms over time, and have seen, as you know, many examples of them over the last few years. 2010, there were 3 days in a 2-week period where there was approximately 10 or more inches of snow on 3 individual days, and that's what led to these conditions that you see in the photographs with this huge accumulation of snow. So it's a little it's a little surprising. Maybe you think climate change, warming, less snow, but it shows that the system doesn't work in such a simple linear fashion. But ultimately, the expectation would be that, again, we should end up more on the warm side than the cold side of these storms at some point, and see more rain, less snow from these storms in the winter. And we may be there, but maybe not yet.
Yeah, we'll see this winter. So going back to that Groundhog Day image, Erin, I wanted to ask you about the start date for spring, the end of winter. Has it shifted in Maryland? Can you talk about that over the last 10, 20 years?
Yeah, so being a science-minded organization, we want to have a more scientific way to track the onset of spring than Punxsutawney Phil or your other groundhogs. So this map, I'm going to explain what we're looking at here, but this actually goes back to the 1950s at the University of Montana. There was a researcher there, Joe Caprio, who figured out that lilacs would be a great way to get a lot of people interested in contributing information about early season plants. And so lilacs, even though they're not native to the United States, they're a very popular flower because they're very beautiful. They're easy to grow, and they actually grow over a lot of the country. So what Joe figured out was he could distribute actually cloned individuals of these plants to hundreds of people across the country, and have them send in little cards that told him for every year when the lilacs would leaf out and when they would flower. And so we've actually had this data set going since the 1950s, where we have this great record of how these plants that are all genetically identical react to their environmental conditions at all these different locations, and how much temperature and the heat waves and things that lead to their leaf out and their bloom times. So another researcher who's at the University of Wisconsin, Mark Schwartz, he was able to develop a model that would tell you if you have this much temperature accumulated and this many heat waves, then you'll have leaf out of lilacs, and then you get a little bit more heat, and then you'll get blooming of lilacs. And so because lilacs are an early season plant, we can kind of use them as an indicator of early season plant activity across the country. So this map is showing a bunch of tiny little pixels that show the leaf out date for lilacs, an early season indicator, at locations all across the country. And this map in particular is actually showing the difference between this year versus the long-term average. And Dan has talked about this as well. We often use these decadal averages as kind of a baseline or a way to say what it used to be like decades ago. So this particular average is 1981 to 2010. We usually use the most 3 recent decades. We'll be shifting next year to the next 3 set of decades, 1991 to 2020. But for now, we're looking at kind of before 2010, which is really before a lot of those really warm years that we've had. So this map, the colors on the map are showing, similarly to those color bands that Dan showed, it's showing the pixels that are colder, that are later than normal for leaf out dates, and then those that are earlier than normal in the red. So you can see that there's a lot of difference across the country. In the mid-Atlantic in particular, This year was actually a later year than the average. So we're seeing pixels around that area that are either white or kind of a light blue for a lot of that part of the country. In contrast, a lot of the Midwest and the Northeast actually saw a really early spring. So they might have had a heat wave at a critical time that kind of pushed those plants to leaf out earlier than average. So if you go to the next graph, breaking down to look at Baltimore in particular, so this might look similar to that other graph that Dan showed of the person walking their dog in the snow. So there's a lot of variation from year to year, and it's important to keep that in mind. And then the dotted line on there shows kind of the pattern, trying to fit all of those points into a trend line there. It doesn't do it very well. There's a lot of variation in the last 10 years for that location. So we're not seeing a very consistent pattern. It looks like it's shifting a little bit earlier. And if we look at some of the actual dates, which I put on the bottom there, that 30-year average that I mentioned for Baltimore, the leaf out date has typically been March 13th. But since 2012, we've seen a shift of about 5 days where the average is March 8th now. So we are already seeing a little bit of shift to an earlier spring leaf out. But like I said, there's just so much variation from year to year. And you can see that this year in particular was below even the average of the last 10 years. So we're going to keep seeing these kind of shifts and changes from year to year, but we have to just really think long term when we're talking about climate changes and look at the bigger pattern.
Yeah, the zigzagging, I think, for plants is, you take your plants in, you put them back outside, and they're going to die because you don't really know what's going to happen. That unpredictability is certainly something that I think we're all experiencing. Were there any other plant species or animals that you were going to talk about, Erin, to just how these changes might impact some species that we know about besides the lilac?
Yeah. So there are a lot of different examples we could talk about, but I wanted to highlight one example in particular. This was a study that we did with a university at Penn State, where she wanted to try to look at the differences in leaf out between invasive and native shrubs across the eastern United States. And she had a number of research sites in Maryland that participated. And so what this graph shows is that overall, you can see that the invasive shrubs are generally a lot earlier than native shrubs for their leaf out timing. And then this is particularly visible at southern latitudes. And in Baltimore, it's about 39 degrees latitude. So it's kind of in the middle of that graph, but you still see quite a big difference, of weeks in between when invasive shrubs are leafing out versus native shrubs. And so it's thought that, invasives, they're very good at what they do. That's why they're invasive. They're able to come to new places, and they're kind of generalists, and they're able to adapt to different conditions. And so they have that flexibility to respond to that earlier spring. So they're able to take advantage of that. And actually, that can cause issues with competition. And that trickles down to a lot of other things in their ecosystem. So invasive and native shrubs both occupy the understory of deciduous tree canopies. So when that time of year when it's early spring and the trees haven't leafed out yet, that's a really critical time for everything on the forest floor to be able to use that sunlight. And so if the invasive shrubs are kind of coming in and taking over and leafing out early, then they're restricting that sunlight from the forest floor. And a lot of things like early spring ephemerals like trillium and other little crocus and plants that grow on the forest floor. And then also animal salamanders and things like that aren't able to get the sunlight they need at a critical time. So there are lots of big changes that are coming, I think, with future warm years where we're going to have more and more invasive leaf out. And then I also just wanted to mention so an example of one tree that you can look at on one of our tools, our visualization tool, is the tulip tree or the tulip poplar. And so if you go to that link, we can actually see a lot of changes. If there's a species that you're interested in, I invite you to go to our visualization tool and see if you can come up with a graph to start looking at the data that have been recorded through our organization. And this one shows the leaf out for tulip poplar over the last 10 years. And it's loading at the moment. And so again, we're looking at a number of different years, and each dot is a different plant that was observed. And so again, you can see there's some variation from year to year, but if we look at that line that goes across, that's kind of the pattern that we're seeing. it is shifting to earlier each year. And that's a fairly good fit for a line to show you that that is kind of the pattern that we're seeing there.
Great. I just put the link to the NPN website, and this tool that you're using is it under the it's under data, the data
yeah,
tab?
on the data menu, yeah, under
Visualization.
tool.
Yeah, so put that in the chat as well, so people can look at that tool. That's actually how I found Erin. I discovered this tool and spent, I don't know, 6 hours or something playing with it, looking at different plants in Maryland. So I find it fun, but I'm a plant nerd. Okay, so I was wondering if I think people have, you know, who are part of this panel, a part of this audience might want to know if they can get involved in any aspects of your research. If you could speak to that, maybe start with Dan.
Sure. So on this slide, I put 3 things that I think folks in this community might be interested in. On the top, this is the National Weather Service, which is part of the agency. I am a member of NOAA. They do offer the ability to become what's called a cooperative observer, where you can basically affiliate with your local Weather Service office and operate a measurement station if you'd like to contribute data. They do have some really stringent requirements to do this, but you can read more to do it on that website. And maybe some of you are sort of interested in that kind of both service and also activity. It really gets you to be very cognizant of the weather. If you want to, you know, be more like Bob Turk, this is a way to do it, and also improve our weather forecast as well. In the middle and the graphic on the right, there's a website called oldweather.org. And I think especially given that we probably have some history buffs on this phone call, this is a really cool activity where they noted that a lot of old ship logs from trading ships to other sailing ships, you know, going back even into the 18th century, they would routinely keep measurements of atmospheric pressure. It's really the main way that they would have a sense of what was going on with the weather, how it was going to change, and to try to prognosticate those changes. And so there are all these analog weather records from old ships. Even doctors used to keep weather records because they thought that atmospheric pressure was a significant guide for ailments. And this project basically is asking you to help digitize these records, to take what you read on the page and turn that into data by typing it in. And ultimately, this data is actually used by climate scientists to help extend our records of climate way, way back. We now actually have models that go back into the mid-19th century using this data that can show you hurricanes in the Atlantic or the Pacific, or large heat waves in the Midwest before, you know, parts of that part of that country were even habitated widely. So it's really, really valuable to give us a long record of weather, and I think it would be really fun for history buffs too, because you get to see all this other cool stuff that's in the records. And then the last thing is this image on the left from the New York Times Magazine, which talked about the Cloud Appreciation Society. I really got into climate and weather just because I used to look up at the sky as a kid. I used to marvel at thunderstorms developing. There's really, you know, nothing more calming and stimulating than pulling a chair out and looking at a large cumulonimbus cloud develop on a summer day. I encourage you to do it. It's a Zen moment, but it'll also wow you at the environment that we exist in. And it's, you know, as I say here, a free and egalitarian entertainment. Everybody gets to view it and experience it. It's going on all the time in our atmosphere right above us. So if that's appealing to you, I think you'll really enjoy this kind of fun British Cloud Appreciation Society, which you can actually become a formal member of. And there is a community, and it's kind of a fun community to be part of. So I would encourage that as well.
I see there's a cloud spotting app, a cloud a day app. I'm going to download that as soon as we hang up. We're finished.
Oh, great.
Yeah, and so if you're interested in learning about phenology, the best way to do that is to go outside and start observing the plants and animals where you live. So we have a program called Nature's Notebook, and the data that we were just looking at on the visualization tool for the tulip poplar are actually data contributed by what we call citizen scientists or community scientists. You don't have to be someone with that background to do it. We invite anyone across the country to sign up to be an observer. You create a site. It could be in your backyard or somewhere else that you go to frequently. And then you can add different plants or animals to observe. And there are lots of benefits of doing this. You get to spend time outside, and you're contributing to this big national data set that helps us understand climate change. And it's pretty easy to observe. You just sign up for an account. We have an app that you can use to submit data. We have lots of training resources and lots of tools to help you know exactly what to report. And then you can also, if you like paper data sheets, we have that too. So you could take old-fashioned paper data sheets and just turn your phone off for a while if you want to do that. So the website is there on the slide. I think Lynn already put it in the chat. So I welcome you to check that out.
Great, thank you. We have one question in the chat already, but Martha is going to read some of our questions.
Thanks, Lynn. And actually, you all are so good at anticipating what people want to know. You've answered a lot of, I think, what people have already put in. But one question along the topic of clouds, and perhaps Dan, since you are a cloud fanatic, you can answer this, but do clouds tell us anything about our changing climate?
Oh, that's a really good question. So there are some changes happening in cloud patterns around the world. Not so much in the Mid-Atlantic region, but especially parts of the ocean region. There are changes in coastal clouds in the East Pacific that have been observed. And there is the expectation that clouds should change over time, favoring different kinds of clouds. We have clouds at a variety of different levels in the atmosphere, and they, from the ground, you can see they have quite a different appearance. There's thin, wispy cirrus clouds that are really high up. They're made of ice crystals, and then the low puffy clouds, like on a nice summer day, that you might see, which are much closer to the surface. And each of these clouds does have a different effect on climate, actually, because clouds, in some cases, reflect energy back out to space and help cool the planet. In other cases, they actually let energy in, but then trap energy on the way back out. So those cirrus clouds, for example, do that, and they warm the planet. Overall, the science is there's still a lot of work going on to understand clouds and climate. It's really, clouds are very complicated, and understanding all the mechanisms that control them is a tough challenge. But in general, it's expected that clouds will actually serve as what's called a positive feedback to climate change, and actually, as the temperature increases, clouds will encourage the temperature to increase more, actually. So positive is a bad thing with climate. It makes the system continue going in the direction it's already going. But there's a lot of research going on that now.
And Dan, as you alluded earlier, there are likely a lot of history buffs on today's program. I'm really glad that you pointed out the old weather. That seems like a really cool project that's happening. But some people are wondering where they can access historic weather data. Both you and Erin have shown, weather over time, and I'm sure that they're contextualized by your research, but I'm wondering if there's a site or a location where people can find that on their own.
Yeah, sure. So at least for climate data, I should have plugged this on my slide, but my office also runs the website climate.gov, which is a portal to a lot of writing on climate that I think folks will find to be really accessible and interesting. And then also it's a portal to a number of data tools. There are just endless data tools out in the federal government, and also universities and NGOs operate that can help you access different kinds of data. And, Erin showed an example of this with the Phenology Network. I showed information on one of my slides where there were the historical data, and then the blue and the red lines. That's from the Climate Explorer, which you can Google and find. There is also the National Centers for Environmental Information operates a website that I will put the link in the chat to, and you can pretty quickly get down to a county, even a city scale, and you can look at data, things like precipitation, maximum, minimum temperature, and make your own graphs if you'd like, for different regions and different parts of the world, actually. So I'll put a link to that in the chat.
Okay. Erin, do you want to add anything?
Sure, yeah. So if you are interested in learning more about, I guess, historical phenology data, I would invite you to look up Thoreau. So Henry David Thoreau actually kept detailed records of phenology at Walden Pond. And there's been a lot of research done by Richard Primack in his lab about comparing what's happening now with what Thoreau recorded. So it's kind of an interesting study of how things have changed across the century. And then also Aldo Leopold and his daughter Nina Leopold Bradley also kept records in Wisconsin. And so that's another great data set that's been, there's been some research done on that to see how things have changed since then. So I probably would start there. There's probably a lot of other long-term records out there, but those are the two that you would find the most information about.
And I know throughout the course of today's program, there's been all of these links and like wonderful resources that have been thrown out there. We're putting a lot in the chat, but I do want to reassure everybody that I will be sending out a follow-up email, and I'll kind of condense some of this information in one place. So it's in your inbox. You don't have to worry about missing something from today's program. There was also a question about accessing the full program. After we close out, we will lightly edit the program and we will be putting it up on our website for you to see in full or share with anyone who may have missed it. So don't fear, you'll be able to re-access this for the future. I'm gonna, I think, wrap up with maybe one question along the lines of precipitation. Barbara says that she's noticed that there appears to be more mixed precipitation. So like sleet and snain, which I know has been a term that's been thrown around lately. Is that accurate? Is there anything, you know, that we can deduce from that observation?
Sure, so I can try to tackle it. I didn't look at that specifically. There are records, for example, from BWI where they take into account those different kinds of mush, which I think all of us can agree we hate. I don't know that there's a sleet fan out there. You know, that kind of goes back to the explanation earlier about the freezing line in a given storm. And we have had these really miserable experiences, especially the last couple of winters, where we have had the ingredients for a really nice snowstorm. And then the storm ended up kind of being too far to the west. And we ended up right on that freezing line where you get rain, you get sleet. In one case, I recall last winter, we were back and forth. It was like snowing and then sleeting and raining and then sleeting and snowing and sleeting. And it couldn't make up its mind what the storm wanted to do because we were right on that line. And you know, that is if we are going to transition from more of a snowy to a rainy environment in the winter, you would also expect to see some of those kind of transition types of precipitation as well as that change takes place. So more of that snow, more of that sleet, more of that freezing rain type of precipitation. And I'll just mention freezing rain technically is rain that's falling on cold ground, so it freezes on contact with the ground. Whereas sleet are actually little ice pellets that are falling from the sky, but they both stink in my book.
Agreed. Well, we are at the top of the hour. I want to thank all of you for being here today, and thank you, Lynn, for bringing your work to the Maryland Center for History and Culture and prompting a discussion about this. It's really fascinating information, and I think everyone who's been on today's call has probably learned a lot. So thank you all. And then I just lastly want to remind everybody that Losing Winter is on view at the Maryland Center for History and Culture through July of 2022. You can go online to our website, which is mdhistory.org, to see our visitation hours and to plan your visit. So thank you all. Have a wonderful day, and we will wish the best for our warming planet. Thank you.
Thank you.